Good morning, guys. And today, our next module, which is 1.7 in Unit 2, this is all about understanding rates and unit rates. And you can see our learning target. I can understand how a rate is related to a ratio and use ratio and rate reasoning to find a unit rate. So we'll be talking about what a rate is, what is a unit price, what is a unit rate. All right, we've already talked about ratios. So I've made a table already on the board for you to see a difference between a ratio, a rate, and a unit rate. So just let's look at this really quick so that we understand what these three are. All right, so as you can see, what is a ratio? We know that a ratio is a comparison between two quantities using division, right? So therefore, look what it's saying, a comparison between two quantities in which for every A unit of one quantity, there are B units of another quantity. And where I'm talking about units, they can be alike or they can be different. It doesn't matter. In ratio, it can be alike or different. So for example, if I say 6 laps to 4 laps, okay, so this one did 6 laps and another person did 4 laps. So that is the same unit. I can also have different units, like I can have 6 laps, or 4 laps in 6 minutes. So those are different units. So when I'm talking about ratio, teacher to student ratio in the classroom, blue-eyed students to brown-eyed students in the classroom. So you can see these are all ratios. It's a comparison of one quantity to another using the division sign, okay? So what is a rate? A rate is a special kind of ratio, all right, in which the units are different. So units are not the same anymore. Units are different, and that's what makes it a rate, okay? So units are different. For example, 6 minutes for 4 laps, and I put another example. For example, we have 140 miles in 2 hours. Okay, so 140 miles in 2 hours. So as you can see, the miles and the hours are two different units, and that's what makes it a rate. Okay, so unit rate is when I take the rate and I put it over 1 unit. So my denominator is always going to be 1. So a rate in which the first quantity is given for every 1 unit of the second quantity. And in this, the units are different, okay? So for example, I have 1 5/10 minutes per lap, 2/3 laps per minute. So that per minute is like what I'm talking about. Your denominator will be 1. If I convert this rate over here, 140 miles in 2 hours, to unit rate, it would become 70 miles in 1 hour. So that's basically what the unit rate is per unit of the second quantity, okay? So let's go ahead and we are going to quickly understand rate and unit rate. I'm going to erase this so I can write over here. Okay. So let's say I'm going to give you an example that Luciana ran 4 laps around the track. 4 laps around the track. 4 laps, okay, around the track at her middle school in a total of 6 minutes. Okay, total of 6 minutes. So again, Luciana ran 4 laps around the track at her middle school in a total of 6 minutes. Suppose she ran at a constant speed. So I am going to just make this into a bar diagram to show the relationship between the number of minutes and the number of laps, okay? So I have 6 minutes. So I'm going to make a bar diagram over here. We have 6 minutes. And in 6 minutes, she did 4 laps, okay? So that means I'm going to break this into 1, 2, 3, and 4. Okay, so we have 4 laps, and each of this is 1 lap. Okay, each of this is 1 lap. So if I'm showing it on a bar diagram, this is how I would show that. Okay, now, so this bar diagram is representing the relationship between the number of minutes and the number of laps. So the ratio of the number of minutes to the number of laps is how much? It's minutes to lap. Okay, so if I'm saying minutes to laps, listen to always what I said in the last video. Always look at the question part. What is it asking? Okay, then you go to the numbers. So if it's saying minutes to laps, I am going to do 6 to 4, because 6 minutes to 4 laps, and that is what my ratio is. Okay, so because the units, minutes and laps are different, this kind of ratio is called a rate. This is called a rate because they are different units. And a rate is a special kind of ratio in which the units are different, and the ratio 6 to 4 has the associated rate 6 minutes for 4 laps. Okay? And to find the number of minutes per lap, we are going to find the value of each section, because so if I'm trying to find the minutes per lap, we're going to find the value of each section. And so what I'm going to do is 6 over 4, and if I simplify, what do I get? I get, this is equal to, if I divide by 2 and I divide by 2, what do I get? I get 3 over 2. All right, and what is 3 over 2? It is 1 and 5/10 minutes per lap, because I'm just going to divide the numerator by the denominator. So if I divide 3 by 2, what is half of 3? It's 1 and 5/10 for 1, right? It's 1 and 5/10 for 1, and this is called a unit rate, because what I'm going to do is I'm finding the minutes per lap now. Okay, so if I make a bar diagram again, and I'm trying to show this to you, I have 1, 2, 3, 4. Okay, and this is 6 minutes. This whole thing is 6 minutes. And then, as I just showed you, how to find how much each lap is. Okay, how many minutes it's going to take per lap. It's going to be here, 1 and 5/10 minutes, 1 and 5/10 minutes, 1 and 5/10 minutes, 1 and 5/10 minutes. Okay, so Luciana ran at a rate of 1 and 5/10 minutes per lap. Okay, so this is minutes for 1 lap. That's basically what this is. Okay, so this rate is called a unit rate. This is called a unit rate. Okay, if I write it in this format or in this format, it is called a unit rate. And a unit rate is a rate in which the first quantity is compared to 1 unit of the second quantity. And the phrase per is used to describe unit rates. It means for each. Okay, it means for each. So Luciana, now let's do another one. Luciana ran, we can also do this if we are trying to change how many laps. So in this it was saying minutes per laps, right? Now if it says Luciana ran 4 laps in 6 minutes. So this one. Okay, suppose you want to find how many laps she can run in 1 minute at the same rate. I am going to show you the bar diagram now. So we have, I'm going to erase this. Okay, And so here we go. I'm going to do this. We're going with this one now. 4 laps in 6 minutes. And suppose you're trying to find how many laps she can run in 1 minute at this same rate. So we have 4 laps. That's what we have. And how many minutes do we have? 6. So we are going to do 1, 2, 3, 4, 5, and 6. All right. So these are all 1 minute, 1 minute, 1 minute, 1, 1, 1, and 1. These are all minutes, okay? So I'm just trying to make the visual so that you can understand what we are doing. All right, so these are all 1 minute, okay? So the ratio of the number of laps to the number of minutes is how much? 4 to 6, right? This is 4 to 6. And what does this mean? That this is 4 over 6. So see how this has switched now depending on what is asked of me. Earlier it was minutes per lap and now it is laps per minute. That's what it's asking. All right. So this becomes, if I'm dividing by 2 again, this is 2 over here. 2 laps over here, 2/3 lap per minute. Okay. So we're going to have 2/3 lap per minute. So if I have 4 laps and I am trying to see how many laps per minute? Okay, 1, 2, 3, 4, 5, 6. All right, so this is 4 laps. This whole thing, okay? And so this is going to be 2/3 lap. Each is 2/3. 2 to 3, 2 to 3, 2/3. Okay, here we go. All right, so the ratio of the number of laps to the number of minutes again is 4 to 6. And so 4 laps in 6 minutes, which if I'm simplifying, because if I divide 4 by 6, I get 2 to 3 or 2/3. So ran at a rate of 2/3 lap per minute. If I'm trying to find the unit rate of this. Okay? All right. So let's do an example. And I'm going to show you a question. All right. So a scientist studying hummingbirds recorded that a hummingbird flapped its wings 1,590 times. It's flapping its wings in 30 seconds. Okay? So flapped its wings 1,590 times in 30 seconds. Okay, so I'm just writing it out as a ratio. And assuming, so again, let me just read that question again. A scientist studying hummingbirds recorded that a hummingbird flapped its wings 1,590 times in 30 seconds during normal flight. Assuming a constant rate, how many times did the hummingbird flap its wings per second? Okay, so I'm going to use one method I can do is a ratio table. Okay, one method I can do is a ratio table. Okay, so I'm going to make a table. And here we go. All right, and we are going to talk about number of wing flaps. Okay, wing flaps. So this is my number of wing flaps. And 2, my number of seconds. Okay, number of seconds. Okay, and so I've been given 1,590 for 30. So 1,590 times the wing flap for 30 seconds. So if I'm trying to find the unit rate, what do? Always divide the numerator by the denominator. Okay, so if I divide the numerator by the denominator, so that is I am dividing by 30. Whatever I do to the numerator, same thing to the denominator or to both of the ratios in order for me to get unit rate. Okay, and I end up with 1 over here because 30 divided by 30 is going to give me 1, and 1590 divided by 30 gives me 53. Okay, so that gives me 53. So look, 1590 divided by 30. Okay, so I have 5 times 3 is 15, and I get 150. I get 9, bring this down. Okay, and then I get 3 times 30 gives me 90. So that's how I got that 53. Okay, so if I'm looking at this, what did we do over here on a ratio table? We scaled backwards. Okay, so you scale backward in order to get the unit rate because we are dividing in this case. Okay, now another thing I can do, I can write and solve an equation stating that 2 rates are equivalent. So I'm going to use equivalent rates. Okay, equivalent rates. All right, so what I can do, yeah, I can definitely do, 1590, 1590. We have the wing flaps to 30 seconds. Okay, so this is my seconds, this is my wing flap. Okay, how many times, number of wing flap, and then all I can do is straight up simplify because in a unit rate, what should my denominator be? Denominator should always be over 1 because 1 of that quantity, right? So look, I can just simplify over here, okay, straight up. This means I'm dividing by 10, right? Divided by 10 right there, I'm simplifying. And then if I have 3, I know my divisibility rules for 3. If I add up the digits, 1 plus 5 plus 9, it should be divisible by 3. What is 9 plus 1 is 10, plus 5 is 15. So I know that 15 is divisible by 3, right? So knowing my divisibility rules. So I am going to take this off. I am just simplifying over here. So I'm dividing. Okay, and I get 5 times 3 is 15 and 3 times 3 is 9. So that's basically what I've done. I've just divided both the numerator and the denominator by 30. Okay, or basically I've divided the numerator by the denominator. Okay, so I end up with 53 over here. All right, because we are trying to make the same ratio. So I can also show it like this. Yes, here you go. I've divided by 30 and I have divided by 30. So this is another way where we are setting up our equivalent rates. All right, so let's talk about unit price now. We've talked about what a unit rate is. We've talked about how we can solve this. Now let's quickly talk about unit price. Okay, so, okay guys, so if I have unit price, we talk about a grocery store sells a 6-ounce container of yogurt for 78 cents. Okay, 6-ounce container for 78 cents. Okay, and the store sells a 32-ounce container, for $3.84. For $3.84. All right. To determine which is the better buy per ounce, find the unit price of each item. So the unit price is the cost per item. Okay. Unit price is the cost per item. Cost per item is the unit price. All right, and you can use what you know about unit rates to find a unit price. So let's talk about the 6-ounce container, this one here. So let's start with the 6-ounce container, and then we'll do the 32-ounce container here, 32-ounce container over here. Okay, and so what we're going to do, we have the price, and we'll just make a table, and then we can of course show it based on equivalent ratios. Okay, so we have price and we have ounces. We have price in dollars. Okay, this is in dollars, and we have the ounces, and same thing over here. Okay, so we have the price in dollars and we have the ounces. So now we can see that we have what? We have 78 cents for 6 ounces. 78 cents for 6 ounces. On this one, we have $3.84 for 32 ounces. For 32 ounces. All right. So what we're going to do, we are definitely going to scale backward because we are trying to find unit cost, right? So we are going to scale backward. And for both of them, because we are trying to find per unit. Okay, so in this case, I'm dividing 7,800 by 6. Okay, I'm dividing by 6, whatever I do here, same thing here. And why am I dividing by 6? Because my denominator has got to be 1. Remember, price or money is always going to be the dividend because I'm trying to find the cost per item. So I always divide the money by the quantity. Okay, so 7,800 divided by 6, and 6 divided by 6, I'm getting over here per ounce, and that's what unit cost is. And when I divide 7,800 by 6, I'm going to end up with 1,300. Okay, I'm going to end up with 1,300. And then in this case, I am dividing by 32. Okay, so divided by 32. Whatever I do here, same thing here. And 32 divided by 32, I get 1. And 3 and 8,400 divided by 32, I'm going to get 12 cents. I'm going to get 12 cents. All right. Now, per ounce, the 32-ounce container of yogurt is the better buy because the unit price is less than the price of the 6-ounce container. And this is the one very often children, you know, they just go straight up and they pick the bigger decimal, and they like, you know, that bigger is always better. But no, when you are paying, you want to have more money left with you, because then that's why we go for all these discounts and sale prices, etc., because we can buy more with the money we have. So whenever we are looking at price, please remember that if you pay less, it is good for you because then you will have more money to spend. All right. So in this case, as we can see, if I have 13 cents and I have 12 cents per ounce, I know that I've paid less for 12 cents per ounce. So therefore, this one is going to be the better buy. Better buy. Okay, so, all right, let's do one last example to find the unit price. And, okay. So, for Carolina's birthday, her mother took her and 4 friends to a water park. Carolina's mother can pay either $130 for a 5-pack of student tickets, okay, for 5-pack of student tickets, okay, or $28 for each individual student ticket, or $28 for each ticket, okay, for one ticket. So if I'm looking at this, which ticket payment option has the lesser unit price? So the unit price is given for buying the tickets individually, which is $28 per ticket. So we already have this one, all right? And we're going to find the unit price for the 5-pack of student tickets. So if I have the 5-pack, once again, if I have a ratio table just to show you, okay, so I have the price in dollars and I have the number of tickets, okay. So I'll have to scale backwards for this one because I'm going from 130, okay, and for 5-pack, right? So I'll have to scale backward again, all right, and I'm going to divide by 5 because I'm trying to find the unit rate, okay? And if I divide 130 by 5, okay, I know that 2 times 5 is 10, right? And I get 3 remainder. I bring this down, and 6 times 5 gives me 30. Okay, so this is going to be, the price is going to be $26. So when I'm looking at this, we've scaled backwards to find the unit price. And so which price is going to be the better option? So if I'm looking at $26, and then I'm looking at that one, which is $28. So $26 is less than $28, right? So $26 is less than $28, and so that is the lesser price. So the 5-pack ticket payment option has the lesser unit value or the unit price because $26 is less than $30, okay? So this is literally what this lesson is about. And once again, I have this more in depth in the first video that I have created on rates and unit costs. So the module 1.7 can be paired up with the other video also if you need deeper understanding. All right. Have a fabulous day, everyone.